Okay, we're going to review functions. So what are the parts of a function? We've got a few different parts. We have the name of the function. We have the function name. We have the function arguments, and then we have the function's return statement. So let's block this out. We've got def. This is the keyword that tells us we're about to define a function. We have the name. I'll name my function foo. And then we have in parentheses the arguments. And I'm going to pass an argument of x into my foo function. Then what am I going to do with my function? I'm going to have a return statement that says x plus 1. Okay. So we've got all the pieces of a bare bones function here. And what can we do with this function? We can call this function elsewhere. So down here, I'm going to say I want to print the result calling foo on 3. And so when we run this code, what are we going to get? Well, let's walk through it. We call foo of 3 here. So what we do when we see a function call, this is a function call, this is a function definition. When our code is calling a function with a concrete value for an argument, what we're going to do is we can just imagine this as going to this function call site and replacing this x. Now we say x is 3. And then return x plus 1. Well, x is 3. So we're going to add 1. So we're going to return 4. And how does a return statement work? A return statement replaces the value. It replaces the function call site with the value that comes after the return statement. When you see a return statement, you're going to take the value after that return statement and use this value to replace the call site of the function. Now I'm going to replace foo3 with the return value of when I called foo with 3, which will then be 4. This function will then print 4. What if I had foo of 5? Same idea. Now I'm calling foo with 5. Now this x plus 1 is going to say, well, I'm going to return 6. I'm going to erase all of this. I'm going to print out 6. Now what gets interesting is if we call foo twice. This is x up here. What if I print out foo of 3? And then I print out foo of 5. So x is going to get 3. I'm going to print this out, and this will print out 4. And then when I call this, it's not going to overwrite x, because once this foo is done, everything disappears, right? And I start anew with now x equal to 5. This is going to print out then 6. So how can we imagine this using our counting method? Well, if we have foo of 3 here, then what it says is, okay, and let's start up here. Let's say we defined x to be 7. Okay, we've got our program. We're going to say, okay, x is a variable that is value 7. Now I go to the next thing. I've defined a function. Great. And now if I go to print foo of 3, okay, I'm going to call 3. I want to print out foo of 3. So these are our print statements that are going to come here. It says print out foo of 3. But I don't know what foo of 3 is yet. So I'm going to create a new space just for my foo of 3 call. And this says I'm going to start a new x. That's 3. This one still exists. This x still exists, but we're working in a new space. This is called a scope. This is the function scope. So now x is 3, and I'm going to return x plus 1. So that's going to be 4. And now the return value replaces the function call site. Right, so this then becomes 4, which means I print out 4. And now I'm done with this. This was like a little post-it note, a little extra workspace that I had. I'm done with that, so I can erase it. I don't need it anymore. It disappears. And now we go on to the next line. We just executed this line. Now we go on to our next line, foo of 5. So I say, okay, I want to print out foo of 5. What are we going to do? We're going to create a new space for foo of 5. And now I'm going to say x is 5. Why is x 5? Because foo creates a new function, a fresh variable called x, separate from the one that we already had. So now x is 5, and the return value is going to be the x in the local scope plus 1, return x plus 1. This x, it's not talking about what's called the global scope, it's talking about the local scope. We already have an x here, we don't need to go looking for some other one. And then I say I'm going to return 6, and the return value replaces the function call site. So we print out 6, and I'm done with this. I don't need my extra workspace anymore. It disappears. Okay, let's make this a little more complicated though. What if I want to print out foo of 5. Okay. So I want to print out foo 5. So now, just like in math, we have to go from inside out. We don't strictly have to, but here we're going to. We go from foo of 5. So I say, okay, well, I want to print out foo of 5, but I don't know what this is here, right? When I call a function, I need to pass it an actual value. So I'm going to reduce just this foo of 5. I'm going to make a clean function space, foo of 5. I'm going to say x is 5. The return value is going to be 6. What am I going to do? The return value replaces the function call site. So it's going to replace this right here with 6. And then I erase this. And now I just have foo of 6. Okay, well, I know how to calculate that. I'm going to take this, create a new space, foo of 6. And I say, okay, well, x is 6. The return value is going to be 7. And what do we do with this 7? The return value replaces the function call site. So this becomes 7. I'm going to print out 7, and I erase all of this because I'm done with it. Okay, let's see one more example. Let's change up our function here. I'm going to define a new function called bar. This is going to take x as well. I'm going to return let's say x. And here, rather than return x, this is going to return bar of x. Let's change this up. Let's make this y. Okay, now I want to print foo of 5. Now what do we think is going to happen? We have foo of 5. So the 5 is going to replace this x here. 5 will be replaced here. And we have another function call. Now the fact that this function call is happening inside of another function, it doesn't matter. We just say, well, x is 5. So this is sort of like writing bar of 5. So when I call bar of 5, I just now look up here and I say, well, my y is going to be 5. And I'm going to return 6. When I return this 6 value, the return value is going to replace the function call site. This whole thing is going to become 6. And then I'm going to return 6, and I should print out 6. Okay, so this is our guess for what's going to happen. Let's test it out. So we still define x as 7 at the top of the program. This doesn't affect anything of what we do later. I only put this here to show you that this global scope isn't going to impact our local scope within each function. So first thing I want to do, I say print. And I say, okay, well, I want to print foo of 5. What is foo of 5? Let's make our new function scope. X is going to be 5. And then I'm going to return bar of 5. But I don't know what bar of 5 is. It's not a value I can return. This is a function call. So I'm going to say, well, I guess I have to create a new function scope for bar of 5 and calculate this. Bar of 5. What does bar of 5 do? It creates a variable y that takes the value that was passed to it. So I'm going to have a y value that's 5. And I'm going to return y plus 1. So y, which is 5 plus 1, that's 6. What happens to a return value? A return value replaces the call site. So this bar 5 becomes 6. And now we get rid of this. We're done with our sort of extra workspace. We don't need this anymore. But now we also have a return value for 6. So we can replace this in the function call site where this function came from. So now we replace this with 6. We're done with our workspace. We delete that. Now we get print 6. So this code here, foo of 5, is going to print 6, exactly as we predicted.